9-7 video notes, practice finding areas of composite figures. So what the heck is a composite figure? So first thing is, a composite figure is a figure made up of simple shapes. So it's a combination of triangles, rectangles, circles, and some things are either like stuck together, and those type of problems is where we're going to use addition. But then some problems like part B is where you have a shape cut out of another shape and you're trying to find a shaded region. So that's where we're going to use subtraction. Alright, so here we go, part A. Find the area of the composite figure. So looking at this shape, it looks like I have a rectangle. Alright, so I'm going to find the area of a rectangle. And then I'm going to add to that the area of this triangle right here. Okay, so the first thing I need to know is I need to know the formulas for both of those, and then I need to know the dimensions to plug into the formula. So area of a rectangle, remember, is just base times height, and this thing has a base, and you got to be careful here because the base of this rectangle is 10. Don't use the 14 because the 14 goes this entire distance, which isn't part of the rectangle. So I have a base of 10, I have a height of 8, so 10 times 8 gives me an area of 80. And then when I go to my triangle, I'm going to use some subtraction here because if the bottom is 14 and this top piece is 10, that means that this piece right here is 4 and then still has a height of 8. And remember, area of a triangle is 1/2 base times height. So 8 times 4 is 32, cut in half is 16. So now the total area for that kind of doorstop looking thing would be 80 plus 16 for a grand total of 96. And then centimeters squared would be my units. So there will be the answer for the first one. And notice that we did use addition for that one to go ahead and solve for the entire composite shape. We used addition. Now part B, we're going to use subtraction because we don't really have a formula for a rectangle with a half a circle cut out of it. But that's exactly how I'm going to solve this thing. So up top here, I'm going to say I have a rectangle minus half of a circle. So formula-wise, it's going to be a base times height minus 1/2, and area of a circle is pi r squared. We go a little bit more in depth of that later on, but hopefully you remember that from pre-algebra days. 0.5 pi r squared. So let's see what we got here. So looking at our rectangle, base is 9, height is 5. So, whoa, sorry about that. So 9 times 5, that's 45. Take away. And now for the circle. The circle is a little bit trickier. So the circle is 0.5 pi. We need to figure out the radius. And right now they don't really show us what the radius is. You know, you might kind of look and say, you know, well, hey, they didn't give us that. But you also have to realize that this piece right here is also the radius. And it should be exactly half of that 5 over there because the whole side's 5, which means that radius is going to be 2.5. So I'm going to go 2.5 squared. So the total I need to plug into my calculator is 45 minus 0.5 pi 2.5 squared. So let's pull the calculator up. Kind of move him over a little bit. Turn him on. Maybe. There we go. Clear that out. So 0.5 pi, and then parentheses, 2.5, close the parentheses. Whoa, said 25. This online calculator is a little touchy. Squared, and that's at 0.5 pi r squared. Enter. Bam. 9.8. So it looks like we have 45 minus 9.817-ish. I'm just going to kind of do it slick, and I'm going to go 45 minus, and then I'm going to use this answer thing down here at the bottom. So I'm going to go second, and then hit the negative key, and it puts that previous answer in there for me. Boom. So final answer is 35.18, and that'd be centimeters cubed, or squared, I mean. But there's your correct answer for part B. All right. Geometric probability. So this is like, what's the chance of something, if you're guaranteed to have an object land in this square somewhere. So let's say that you have some sort of a box, and this square kind of around the edge, this square represents the bottom of the box, and you're dropping some sort of a ping pong ball, or you're dropping something inside, and it's going to bounce around, and it's going to land somewhere and roll and stop inside of this box. Well, we want to know, what is the chance, what is the probability that a randomly chosen point inside the square lies in the circle? So kind of what's the chance that it's going to lie in here? So I kind of like to put this as, so probability is going to be the target area over the entire area. All right, target area over the entire area. So if we look at our target area is a circle. So what we need is, we need the radius of the circle, and the radius of this circle is 2. So our target area is pi r squared. Now, all the possibilities, it has to land inside that square somewhere. So when I'm looking at all the possibilities, this square looks like it's 6 by 6, or 6 squared. So when I work this out, I get that 2 squared is 4 pi all over 36. Now right now I could go to the calculator and punch that in. I'm kind of old school, so I like to do a little bit of canceling. 4 goes into 36 9 times, so 1 over 9. So some tests, if they wanted to leave pi in there, I have a pi over 9 chance. All right, but let's go ahead and let's figure out what decimal that would be. So we'll pull up our calculator. We're going to go pi divided by 9, enter. And remember, it should be a number between 0 and 1. 0 means it's impossible, 1 means it's guaranteed to happen. But this one is about 0.349. So if you want to change this to a percentage, so we could say this is the probability, but if we want to turn it into a percentage, we can say we have a 34.9% chance of landing in that circle. Now to me that's kind of crazy looking, because if you look at that and you're at a carnival and you were going to bet like whether or not it was going to land in there, it almost looks like it might be closer to a 50-50 chance, but it really isn't. And if you go in, another way to kind of do this, I guess, if you didn't really have formula knowledge, was you could go in there and you could kind of count squares. This would not be quite as precise, but it looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So right now we have 20 squares on the outside. And then you got pieces. You got 1 and that little guy. So almost 2, almost another 2. So you got about another 4. So there's about 24 squares of the white. And then if you go in there in the blue, you got 1, 2, 3, 4, maybe 5, 6, 7, 8, 9, 10, 11, 12, but a lot of those weren't full, so I'm not going to count these other ones. So that kind of makes it look like it's maybe closer to a half, because there were 12 blue, 24 not, but that gives me about a 50-50. But that's not as true as using the formula up here. So that's what you're going to want to do on all your problems.